Okay, hello class. Good afternoon. Tuloy lang natin yung lesson, um, yung Transients in second order circuit. So, tatapusin na natin chapter today. Tagang haba ng chapter na. Ayan. Okay. So, last time, ginawa natin is that yung series RLC undriven yung ginawa natin. So, meron nagkaroon ng tatlong cases. Merong underdamped, overdamped, tsaka critically damped. Okay, now itatry natin yung driven naman. So, ang difference lang nung from last time is that, syempre may source to, may voltage source ka. Pero dito kasi may particular solution ka na. Yung sa last time, walang particular solution, puro homogeneous lang. Okay? Okay, so suppose we have this circuit. Meron kang capacitor, inductor, and then tawag dito, voltage source. Okay? So, syempre, ganun pa rin pag nag-KCL ka. No? KCL sa VC. So, determine muna natin yung mga current. Okay. So, pansin mo naman, IC pa ganun, yung IL pa ganun. So, therefore, IC is equal to IL, ay, 0. So, lahat ng incoming 0. Tapos, nasa kabila lang both current. So, therefore, this gives us IL negative C dVC over dt. Tapos, KVL ka. Okay, KVL ka. Negative VC plus ILR. Tapos, VL equals, plus V in. Okay? So, si VL, LDI dt, plus V in, and then plug in mo yung mga dito. Okay? So, magiging negative yung first three terms. Negative, tapos negative, negative, dahil may negative sign dito. So, therefore, lipat ko na lang sila on the other side lahat. So, I have VC plus ILR, which is just RC dVC dt. And then, this one, so L DIL, so LC d squared VC dt squared is equal to VIL. Okay? Okay. So, ito na yun. I-divide lang by LC lahat para magmukhang neat. So, we have this kind of equation. So last time wala lang tong equal to 0 lang ito. Equal to 0. Okay? And then we have this state variable equation. State equation. Okay. Siyempre, yung homogeneous part, as usual, mukha siyang exponential. Okay? Exponential. Diba? From last time, lagi naman ganun eh. Laging A1 e raised to S1. E plus A2 e raised to S2. Tapos yung S1 and S2 natin, nagiging imaginary sila kapag underdamped. And then, magiging real numbers kapag critically and then overdamped. Tapos, hindi sila mag-oscillate kapag yung latter two cases yung nangyari. Okay, so ganun pa rin. Walang bago. S1 and S2 would be something like this for your homogeneous part. Now, we just simplify our discussion. Isang case na lang itatakal natin. So, assume natin na underdamped lahat. Okay? So, underdamped. So, ibig sabihin, mas maliit tong alpha kaysa kay omega naught. So, therefore, this whole thing here is an imaginary number. And this makes your exponentials become sinusoidal. Okay? So, itong VC natin, yung whole solution natin is VC. Equal siya sa particular and then homogeneous part. Tapos, ito na yung homogeneous part natin. Okay? From here, magiging ganito siya. Okay, diniscuss na natin to last time. Tapos si omega D would be the quantity na yung nasa loob. Okay, binaliktad lang yung omega D. Okay, so we have this kind of equation. Tapos si A1 and A2 malalaman mo siya kapag binigay na sa'yo yung initial conditions. Okay? Okay. Kunyari ito yung solution, may makukuha kang solution dyan sa A1 and A2. Okay. So, ang kailangan natin is yung particular solution. And then, wala pang value yung Vin natin, di ba? Vin lang siya. So, for a step input, so kunyari ito yung Vin natin. Yung Vin natin. Tapos, step input siya. Ibig sabihin lang nung, kung naaalala nyo pa, yung U ay 0. U of t is just 0 for e less than 0. And then 1 kapag e greater than equal to 1. Ay, 0. Okay. So this on the right hand side is a constant. So ang hula natin for this particular solution, yung hula natin maganda would be a constant also kasi pag constant pinili mo, 0 na siya dito, 0 na siya dito, pagpapantayin mo na lang dito sa part na to. And amazingly, by inspection, makakita mo na kung ano yung magpapantay sa kanila. So 1 over LC VCT must be equal to 1 over LC V. Okay, kitang-kita mo na kung ano yung VCP agad. Okay, so VCP is just a constant, which is yung strength ng step input mo, which is V naught. Okay, therefore, yung complete solution mo would be this one. Pinlog in lang natin yung V naught dito sa part na to. Okay? And then, syempre, para makuha yung inductor current, gagamitin mo lang yung state equation mo, which is yung nakuha natin sa KCL, itong part na to. Okay? Derivative mo lang, tapos multiply by negative C. Okay? Medyo nakakapagod yung derivative in this part kasi makikita mo ito siya. Pero madali lang naman. B2. Okay? Okay. So, yung derivative nakakapagod lang kasi mag-ano ka, chain rule ka pa tapos multiplication pa tong dalawa. So, yung derivative mo muna to tapos times ito plus yung derivative naman ng mga cosines and sines multiplied by this one. Okay? And then you can regroup them to make it look like this. Okay? Actually, parang hassle nga pag kapag nilagay mo siya agad sa ganitong form. Kasi mas madali kung dito ka magsisimula. Tapos plug in mo muna yung values ng A1 and A2 kung malalaman mo na siya. Kasi mamaya 0 naman pala yung ibang constant mo. Tapos ang hassle, ganito pa yung gagamitin mong form. Okay, mas madali siya na mula dito ka na manggagaling. Okay. Okay, so suppose meron tayong initial conditions given by VC of 0 and IL of 0. So, syempre, gagawin mo lang pag binigyan ka ng ganung initial condition, pa-plug in mo yung t is equal to 0 sa mga equations mo. Okay? So, pag pinlog in natin yung t is equal to 0 here, yung exponential magiging 1 na lang. Then, cosine would be 1, sine would be 0. Therefore, matitira sa VC of 0 mo is just B0 plus A1. Okay, kuha ba yan? So, B0 plus e raised to 0 plus A1 cosine 0 plus A2 sine 0. Okay, 0, 1, 1. Okay, we have this part. Okay? And then, in a similar manner, for the IL of 0, plug in mo lang yung 0 sa mga t mo. So, kita naman, evident from here na yung first term lang magsusurvive and then constant na 1 lang yung mga functions of t. Therefore, you have this factor na may an E1. So, you have that. Okay. And then, ito ba, inspection, alam mo na agad yung A1. Lipat mo lang, no? Ito na siya. To solve for A2, plug in mo lang A1, you have this. Okay. Wala lang. Ano lang to, predicting the steps lang yung ginagawa niya dito. Okay? Predicting the steps lang ito. Kunyari, given ka na ng mga values dito, parang gagawin mo na lang is you plug and play your values into these solutions. Okay? And then, kunyari, uncharged yung capacitor and inductor mo. So, IL of 0 is 0 and VC of 0 is 0. Also, you have these two. Okay, you have these two equations for A1 and A2. Pansin nyo dahil ito ay 0, 0, 0, 0. So, ito na lang yung matitira. Which is this one. Okay? And this simplifies your solution, which is this. Okay, bakit ng author lagi niyang binibigay yung example na to? Okay? Kapag binigay niya yung example na to, binibigay niya yung zero state solution o zero state response. Okay, so this is the zero state response. Okay? And then yung undriven, would be the ZIR. Kasi wala ngang input, kaya siya yung zero input response mo. Okay. So the solution, whenever you have a charged and pag charged and driven, yung RLC circuit mo, or RC or RL circuit, ang mangyayari is that yung total solution niya would be coming from yung charge niya. Ibig sabihin nun, gamitin mo yung ZIR, tapos yung driven niya would be the ZSR. Okay. Okay. Nice. So ito yung solution natin. Overall solution. Okay, balik tayo dun sa itsura ng equation natin para hindi naman tayo lost in life. Okay, so meron kang V0, A1 and A2. A1 and A2 exists. Okay, and then tinransform niya ulit doon sa equation. Pag yung cosines and sines yung ano mo, yung cosines and sines, yung terms mo, pwede mo siyang gawing ganito. Isa na lang, cosine. Kaso nga lang meron siyang argument na tangent sa loob. Okay, negative yung nandito kasi negative yung nandun sa loob mo. So, nilabas. Okay, kasi pwede mo lang gawin yung pag sign, may sign na sign sa loob. Okay. So, yung negative sign, tumatagos lang siya sa sign. Okay. And then, sa IL naman, would be this form. Okay, huwag niyo muna pansinin yung step function, no? Ito lang muna. Okay, let's see why the cosine vanished. Okay, alpha C. Ang A1 natin ay negative V0. Tapos minus omega D. C, ang A2 natin would be negative alpha WD V0 plus alpha V0 over WD. Okay, magsi-zero out nga yung cosine. Okay, so zero out yung cosine, and then for the sine, okay, negative V0 lang yung A1, tapos A2 plus alpha C. Okay. Magiging negative to V0 WD. Okay, and then pag sinimplify mo to using the values of alpha, that is alpha R over 2L, tapos omega D. So ito ay magiging factor out may omega D. So this will become C. Yes, napaka-visible. Okay, so yung factor magiging, kung ipa-factor natin yung negative WD tsaka V0, magiging WD squared C, and then minus alpha plus alpha squared. Tanggalin na rin natin yung C. Okay? Tapos, ang WD ay square root ng omega naught squared plus minus alpha squared. So, therefore, C V naught W. This is, pag square mo, yung loob na lang matitira. Omega naught squared minus alpha squared plus alpha squared. Cancel, cancel. Omega naught squared is 1 over LC. So this is C V naught WD 1 over LC. C cancels out. L denominator. Okay, L denominator tapos V naught over omega D. Okay, nice. Now, you can generalize the solution by adding the step function. Okay, kasi sure ka naman na zero yung ano. For this initial conditions, sure ka na walang voltages at time 0. Okay? So therefore, you can multiply the step function to your equations. Okay? Pwede mo lang siya gawin pag 0 yung initial charges nila. Okay? And then, try naman natin another input. Impulse response naman. Okay, impulse response. Paano ba to? Okay, let's go back to doon sa original circuit natin. Okay. Kapag binigyan ka ng impulse response, lagi mo titignan yung circuit mo, which is ganito. Balik tayo sa circuit natin. Inductor. So this is your V in, your C, your L, your R. Okay, and then assume natin na uncharged initially, no? Uncharged initially, tapos saka ka naglagay ng impulse response. What would be the new initial conditions for your storage elements? Okay, so yung tandaan natin kapag nakaramdam bigla ng changes sila kapag uncharged sila from uncharged tapos biglang nagkaroon ng change if change happens, we can imagine that inductors open circuit sila. And then capacitors would be short circuits. Okay, so let's redraw this. Let's redraw this system. Okay, connect na natin to para mas madali imagine. Okay, so therefore we can get VL of 0. So VL of 0 is just negative V in. Okay, V in. And this is just negative delta, capital delta, Dirac delta. Okay, and then wag muna natin i-zero. No? Pero basically, yes, pag zinero mo siya, ito yung at t is equal to 0, VL of 0 is just negative delta. Okay, closure lang. Mathematical closure. But delta of 0 is undefined. So we won't use that. Okay, so gamitin natin yung variable form nila para hindi sumasabog yung mga variables. Okay, so at t0. Okay, so at t0 ganito yung VL mo. So therefore, if VL is just L di L over dt, we can grab IL. So IL has to be the integral of 1 over L integral ng VL over VL, integral of VL dt. Now, things are nice kasi napasok mo na sa integral yung Dirac delta, which is nice. Okay. And then, assume natin na yung bounds nito would include 0. Okay, so kahit anong integral bounds nito, basta ma-include lang yung t is equal to 0, pwede natin gawing negative infinity to infinity to. Pero wag. Gawin lang natin na 0 plus some epsilon and 0 minus epsilon. Where epsilon is a very small number. Okay, basta mas magawa ko yun. Ang lalabas dito is negative delta, capital delta, over L, which is the initial condition. Okay? Okay. So, ginrab ko lang ulit yung kinuha ko lang ulit yung solutions kanina. But this time, wala pa akong binabago. Okay, so ito yung solution, general form ng solution. Tapos, okay, so kinuha ko lang sila for ease para ma-plug in natin yung mga initial conditions natin. So, initial condition natin would be this, guys. So, VC of 0 is 0. So, plug in ko yun sa general equation natin. Ito yung kanina. But, wala na tayong step, so 0 na yung step input mo. Okay? So, ito yung lalabas na equation. Wala to. Kinuha ko lang yung general form para hindi ako mahirapan i-recall sila. Okay? And then IL of 0 would still be this. At magkaiba. It doesn't matter naman kasi A1 is equal to 0. It doesn't matter. So, dapat parang plus dapat to. Okay. Coming from this. Okay. So, hindi siya nagmamatter kasi 0 naman. Buti na lang. Okay. Ayan. Solving for A2. This is just okay, negative lambda. Lambda pala to. Dito delta. Then, okay. Anyway. So this is negative cancels out. Delta lambda L omega D C. Okay, so ito yun. Okay, nice. So we have our A1 and A2. Therefore, yung VC mo, mas makapadali buhay natin kasi A1 is 0. So we have this to be 0. This guy is also 0. Kasi wala naman tayong step input. Tapos, plug in na lang natin A2 here, which is this one. Okay, that one. Okay. And then, in a similar manner, plug in mo lang lahat ng bagay dun sa IL. This one. Okay? So, mag-0 yung mga A1s. And then A2 matitira. Okay. Very straightforward naman yung itsura nila. Let's check the signs. Baka mali na naman yung mga signs. Okay, so this is 0. This is 0. Negative omega D, C, positive so lambda over L negative. Lambda over L okay. Negative. Tapos next is this part alpha C L omega D. Tapos and therefore may C pa. Okay. Ay, wala ko palang C. LC omega D cancel C. So this must be okay, weird. Bakit siya may negative? Intindihin natin bakit may negative. Okay, sorry. Ito na naman yung hindi ko na-double check yung mga equations. Okay. Sa kabila ba may negative sign? Okay, sige. Kabother naman to. Feel ko mas madali no kapag kinuha natin yung derivative na lang. Okay, feel ko dito yung mali. So, from here, para safe tayo, let this be capital L prime, capital VC. So, capital VC, i-raise mo lambda alpha t sine omega d t. Okay, tapos kunin mo na lang yung negative c dvc over dt, which is your I of L. Okay, so negative c times capital VC is be equal times yung derivative nitong whole thing, which is just negative alpha t, no, negative alpha e raised to negative alpha t, tapos sine omega dt plus e raised to alpha t times cosine omega d t omega. Okay, so now this is easier. Negative alpha times c d c, and this is negative alpha times c, tapos yung VC natin would be the lambda, not lambda over LC omega d. Okay, C. So, ito yung tama. Okay, negative alpha lambda tapos over L omega d, that's negative. Okay. And then the other one, the other constant, let's just double check. So C, negative C, C, tapos times yung omega d. So this is just LC. So cancel, C cancels out. Negative lambda over L. Okay, ito yung tama to. Okay. 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 And then, alternatively, may relationship, may relationship between step function and the Dirac delta function. So, yung derivative ng step function is just equal to the Dirac delta. Okay. Okay. So, yung derivation nito mahaba. Take it as it is na lang. So, medyo isang sem yan sa masters. Kung paano i-prove to mga. So, basically, yung U tsaka yung Dirac delta, they are special kinds of function na tinatawag nating distributions. They are called distributions. Tapos merong coarse distributional analysis regarding these topics. For now, take it as it is. Okay? So we can actually use that information to simplify our lives. So, ang gusto natin mangyari ay ito yung ano natin, di ba? Input natin. So, pwede natin siya isulat in terms of yung input dun sa kabila kanina. So, step input natin. Okay? Yung step input natin is V naught times U, T. Okay? And then, let's take the derivative of that and scale it. Scale mo siya para makuha natin itong kailangan natin. Okay? Okay. So, anong sense nito? So, yung VC natin, VC for the impulse must be equal to lambda naught over V naught. Take the derivative of VC. Lagyan natin prime. Okay, for the step. Okay, so VC for the step, i-derivative mo siya with respect to time, then scale it, depende dun sa impulse mo, height ng impulse mo. So you obtain the answer for the impulse. Okay, so ito, kinuha ko pala. Ito yung solution for the step input function. Okay, ito yung solution doon. So, ang gagawin natin, multiply this, then derivative. Multiply this, then derivative of this whole thing. Okay, so zero out to, and then try to derivative this. Pero syempre mas madali ata kung babalik ka doon sa original babalik ka doon sa original joke. Madali lang pala ito yung derivative dahil constant lang ito. So let's do this. So lambda. Labas ko na yung yung V naught, magka-cancel na siya doon. Tapos yung derivative mo na lang ay 1 minus omega d raised to tapos cosine omega d t. So this is a constant for gamma. Para hindi lang tayo mahirapan. Okay, so that is what I need. Okay. And then, kapag tinuloy mo to, 0 yung 1, omega d raised to ano natin, slowly. Okay, then negative alpha raised to negative alpha. Meron kawang u of t dito. U of t Okay, so cosine omega d t minus gamma tapos c of t plus yung next naman ay e raised to negative alpha t tapos derivative ng cosine which is sine ay, negative nga lang, so we have to put negative sign here, and this is sine omega d t minus gamma times yung loob which is omega d, okay, and then copy u of t, and then lastly e raised to alpha t minus and then sine joke cosine omega d t minus yung constants there. Tapos derivative ng u ay yung Dirac delta. So we have that. Okay. Now, problema tayo, simplify natin. Okay. So, to do that, ayos lang natin yung mga bagay-bagay. Okay. Teka. Okay, so sulat natin dito para nahirapan. Negative omega naught over omega d. Okay, that's good. Tapos, lahat sila may factor na e raised to negative alpha. I can remove that. E raised to negative alpha t. Okay, and then yung matitira sa parenthesis natin would be negative alpha cosine omega d t minus gamma. And then minus sine ay may u of t. Ay, hindi pala natin pwede factor out c of t. Kasi merong Dirac delta sa kabila. Okay, ano to? Minus sine omega d t minus gamma tapos times omega d u of t. Yung mga u of t nakalimutan ko. Okay, and then the other one, the last term is cosine omega d minus gamma Dirac delta. Okay. Okay, sige. So, kung sino makapag-solve na ito mamaya, after class, no? Solve nyo. Simplify nyo lang para ma-produce ito. Ma-produce ito, may bonus na grade. Okay. May trigonometric identity kayo na kailangan. Tapos, ito mag-zero out. Kasi Dirac delta siya and we're talking about time greater than 0. So, maglalaho tong third term. Okay? So, you're left with two terms. Tapos, simplify mo siya. Simplify mo siya. Okay? So, send nyo lang via Canvas messaging. Sir, ito yung process. Sige. Pero ayun, ang point ay babalik ka dito. Sir, pwede i-zoom out. Sorry. Nasa libro to, nasa libro. Kaya pa. Nagloko. Ayan siya. So, yung clue ay kailangan mo ng omega naught squared sa taas. Ayan, screenshot nyo na ano. Try nyo lang ng hindi required. Okay. Send nyo na lang mamaya. After, within this day. Okay, in a similar manner, gagawin mo siya dito. May tatlong terms ka ulit. Maglalaho yung isang term dun. Maglalaho yung isang term. Tapos, dahil Dirac delta siya. Tapos, matitira dalawa. Kaya ma-simplify mo siya ulit back to this. Okay. So, yung omega naught squared, 1 over LC to. So, babalik siya dito sa solution natin for the impulse. Okay? And then, sa IL naman, ayan, dalawang terms yung, ito, try nga natin yung IL. Tingnan natin kung madali. Try natin ulit, sorry. I'm intrigued. D over dt, meron ka negative V naught, omega dl, tapos 3 terms. This is negative alpha. Alpha t, tapos yung kopyahin ko lang yung sign, dt, u of t, and then plus omega d, alpha, ay, e raised to negative alpha t, cosine omega d, t, tapos u of t, and then lastly plus u raised to negative alpha t, sine omega d, t, Dirac delta of t. Okay, so ito, disregard na natin Dirac delta kasi zero lang naman siya whenever it's not zero. Whenever the argument is not zero. Okay, and then, tingnan natin kung tutugma ito dun sa dalawang term na sagutan natin kanina. Okay, for the first term sa cosine, sa cosine, meron siyang omega d, lambda, ay, cosine. So this is lambda, cancel yung V naught, then divided by omega d over, divided by omega dl. Kaso may factor to na omega d, so L na lang. Is that correct? Tingnan natin kung yung tamang term. Okay, tama yung cosine term natin. The next would be the sine term. Cancel V naught. So lambda, positive lambda V naught. Lambda V naught. Ay, lambda delta. Alpha times lambda naught. Okay, is this what we obtain? Okay, tama naman. Na this is lambda times alpha over L omega d. Okay, sige. Okay, iwanan natin sila. Ayan na sila, hayaan mo sila. Okay, sa mga RLC circuit, maganda rin na meron ka ding idea kung ano itsura niya, kung ano itsura nung graphs niya. So meron tayong intuitive analysis dito. Para meron tayong RLC circuit here with this specs. Okay, so may L ka na 100 microhenries, 100 microfarad capacitance, 0.2 ohms resistance, and then you have the initial charges for your capacitor and inductor. So yung capacitor mo may 0.5 volts na nakastore sa kanya. And then yung IL will have a negative 0.5 amperes na nakastore sa kanya. Tapos input 1 voltage. Okay? Okay. So, the general idea sa mga capacitors tsaka sa inductors is that whenever they are in contact with the supply for a very long time, okay, they are in contact for a very long time, ang mangyayari sa capacitor mo is magiging fully charged na siya. So, magiging open circuit yung uh, open circuit yung capacitor. So, kapag charge na siya, charge. Okay, open circuit na siya. So, you have your circuit uh, to look like this. You have it to look like this. Okay? Okay, so mukha na siyang ganito. Therefore, yung IL at infinity mo, wala ng current na mag-flow through dyan. Okay, tapos yung full charge state ng uh, capacitor mo would be Vin. Bakit Vin? Kasi open circuit na nga ito. Therefore, yung ma-measure mo na lang dyan na voltage ay yung voltage ng input mo. Okay? Okay, so we have this kind of behavior at infinity. So we have now the starting points and yung mga values natin at infinity. So let's try to kunyari graph yung VC of t. Okay, so yung VC of t natin, graph tayo. Magsa-start siya at 0.5. Then somehow at infinity, mag-straight line siya at 1 volts. Okay, so hindi ko sure kung saan siya magtatapos. Basta at the end, straight line siya, no? So, not necessarily at this point, no, na around 3.4 milliseconds, no? Hindi, wala. Wala pa tayong idea about that. Ang alam lang natin at infinity, straight line siya, fully charged state na siya, which is yung 1 volt, plus meron siyang initial na 0.5. Okay, so from here, let's try to obtain more tawag dito, information. Okay, kunin natin yung alpha and yung omega naught. So alpha is just R over 2L. You plug in your values kanina. So R is 0.2 and then yung L is 100 microhenries. Tapos same goes with your omega naught. Okay, ganito siya. And then compare mo sila. Okay. Alpha is less than omega naught. Therefore, ang mangyayari sa graph ko ay underdamped. So may mag-oscillate. Mag-oscillate siya na ganyan. Humihina. Okay. And then, kunin ko yung, di ba pag meron kang underdamped state, meron kang sines and cosine na merong omega d. Omega d. Okay, so omega would be your frequency. Omega d would be your frequency. So let's try to obtain that. Omega d is here. Okay. So, plug in mo lang omega naught mo, which is this, alpha, which is this, which is na around 10,000 radians per second. Tapos convert mo na lang to cycles per second, which is 1584 cycles per second. Or kung gusto mo ibang data, 1584 cycles per second, multiply mo na scaling factor ng 1 second, which is around 1,000. Which is 1,000 millisecond. Then you obtain that you have around 1.584 cycles per millisecond. Okay? So, kada isang millisecond, meron ka isa't kalahating cycle. Pero, parang nakakalito pa yun, no? Gawin mo na lang, pwede rin naman ganito. 1 over omega d. So, this is just 1 over 1,584 cycles. Tapos matataas yung seconds. Okay? So, makukuha mo dito sa, ano na to, is around 0.6. Hindi, kulang. Uh, Around this value. Hindi. Divide nyo nga. 6 to, 6. Okay. Double check. Lalabas dito ay 0.6. So, this is seconds per cycle. Okay. So, in terms of milliseconds, this is 0.6 milliseconds per 1 cycle. Okay. Now, okay. So, yung kada ganun mo, 0.6 dapat yan. 0.6 in time. Okay, 0.6 in time. 0.6 milliseconds. Okay. Next, nagkakaroon na dito ng silbi yung quality factor. So, yung quality factor natin, this determines kung gaano katagal siya mag-cycle. So, yung number na yan would determine kung ilang cycles approximately. Okay. So, yung quality factor is given by omega naught over 2 alpha. And yung lalabas na number ay 5. Okay. So, therefore, magsa-cycle ng around 5 times yung graph bago siya mag-die out. Okay. And then next, okay, alam na natin kung ilang beses magsasayaw yung graph natin. Tapos gaano kataba yung isang graph. Gaano siya kataba. It's around 0.6 milliseconds. Tapos, ang kulang na lang is, from this point, does it go up agad or pababa muna? Okay, so tingnan natin yung circuit natin. Circuit natin, 0.5 yung hinahawakan nito. Tapos kung charging siya, syempre pa ganun yung current sa kanya, di ba? Kaso, mapansin mo, initial state nung inductor mo is negative. So the inductor is actually pulling out the energy from the capacitor. So therefore, it is discharging the 0.5 volts. So mula 0.5, bababa ka muna. Bababa ka muna. So bababa ka. Tapos tataas ka ulit. Okay. So kulang sa atin dito ay amplitude, which is hindi natin malalaman kasi hindi naman natin sinolve yung buo. Okay. But the idea is that meron akong 5 cycles around here. Tapos 0.6 milliseconds yung kada isang cycle. Okay, so pag dinrawing mo siya, ganito na itsura niya. Okay? Mapansin mo, this is 1 cycle. Tama, di ba? Tapos may kalahati pa ako. Okay, so 1.5 cycles per second or kung gusto mo, yung 0.6 na sinolve mo kanina. So you have 0.6 milliseconds distance from peak to peak. Okay, peak to peak. Tapos, it dies after 5 cycles. So 1, 2, 3, 4, 5. Then it dies out. Okay. So this is not the exact graph. But this tells you na dapat ganito itsura ng graph mo pag nag-graph ka. Okay? This is not the exact graph. So medyo mali yung medyo hindi ka sure sa amplitude ng mga bagay-bagay. Okay. Alright. So ganito itsura niya. Okay, wala lang. It's a sanity check. Sanity check siya. Okay, next would be 2 capacitor and 2 inductor circuits. Paano pag may, or actually, N capacitor? Pero hindi naman ako magbibigay ng ganda sa exam. Overkill na to. N inductor. Okay, gusto ko lang i-point out kung ano mangyayari pag ganito yung circuit mo. So, dito sa circuit natin na to, hindi natin siya masisimplify, no? Hindi natin mapagsasama yung dalawang capacitor. may problema tayo. Kasi kahit anong Thevenin mo dyan, hindi magsasama tong dalawang capacitor. No? Okay, so kasi minsan meron ka maraming capacitor, meron ka maraming inductor, but in the end, you can lump them out. Pwede mo pagsama-samahin into one big capacitor. That's nice, okay. Babalik ka dun sa last chapter natin na analysis, which is yung RC and RL lang. But for this time, no, it doesn't give you a simpler version. Okay, so your trusty friend, of course, is KCL. KCL ka at this point. Okay. KCL ka at this point. So, pababa yung IC. Pababa din dito. So, lahat palabas ko yung kung ganun. Absurd. Okay, so KCL gives me at V1. This gives me IC plus V1 over R1. V1 minus 0 over R1. Tapos plus V1 minus V2 over R3. And that must be equal to 0. So lahat ay outgoing kaya nasa isang side lang sila. At V2 naman, so guys, kahit hindi nyo masagutan yung mga kung hindi nyo alam paano sasagutan yung mga bagay-bagay sa exam, mag-KCL at KBL kayo. May sayang points kaysa blanco. Okay, lagyan pala na IC1, no? Kasi may dalawang capacitor nga pala. So, the incoming for this node, V1 minus V2 over R3. And that must be equal to V2 over R2. Tapos plus IC2. IC2. Okay, and then IC2 can be written as, yung mga IC mo ay, they can be written as C dVC over dt. Then you plug in those different differential terms there. Okay, you obtain this, guys. Nilipat lang sa second natin, nilipat lang siya. No? Kaya may V2 minus V1 siya. Okay, and then you can isolate, kita nyo dito sa part na to. Pwede nyo mahiwalay itong part na to. Tsaka dito, diba? Tapos in the same way, ganun na rin dito. Therefore, you can separate these two equations. Okay, separate mo sila. So I can write down V2 in terms of tapos plus R3D1 plus D1 equal 0. Joke. Equal na nga pala sa kabila. Okay, so V2 is equal to this. Then you plug in V2 to this part. Then makukuha mo yung equation for, differential equation for V1. And same goes the other way. Okay, so may makukuha kang equation na Hassel. Okay. But kita mo naman yung form niya. Okay, so second derivative, first derivative, then the variable. Okay, then you simplify this, i-lump mo lang siya sa isang constant. I-lump mo lang din to sa isang constant para hindi ka mahirapan. Then you'd go back to those pag-solve ng general solution for a second order differential equation. Mabalik ka dito. So, meron kang general form ng solution mo to look like this. Okay? Look like this, and then, ayan. Tapos, syempre, meron kang values for your alpha and then omega naught nakabase dito. Okay? Okay. Now, titignan mo na parang, okay, nice. Meron din underdamped, overdamped, and critically damped. But it turns out, no, it's not like that. Ang lalabas lang ay pag kinuha mo yung subtraction na yung dalawa, medyo hassle siya i-subtract, pero you get the idea that A, ganyan ba lang itong idea na A squared is just A plus B, A minus B, okay, okay. And then, syempre, okay. So, you just recall your equations. Solve mo itong ganun to. Pag pinag-subtract mo sila, kinuha mo yung nandito sa loob ng square root, pansin mo that they are always positive. Okay, so, this whole thing here, positive yan. Kahit ano mangyari. Kahit gano'ng kalaki itong dalawang to. Okay, positive yung term na yun. So, this one is also positive. Therefore, this whole thing is also positive. Okay, so this, ibig sabihin, ang mangyayari lang is, yung system mo is always overdamped. Overdamped. Okay? So, mangyayari is that e raised to negative s prime, t yung mga itsura ng mga function mo. So, therefore, they're dissipative. And ano naman siya, no? Intuitively naman na this is just an RC circuit. Therefore, magdi-dissipate lang siya. Okay? Okay. Wala lang. Hindi ako magbibigay ng ganito sa exam. Masyadong overkill to. Okay. And then, if you extend this to N capacitor or N inductor circuits, ganun lang din mangyayari. Magkakaroon ka lang ng N equations. Okay? So, sa 2 capacitor circuit natin, nagkaroon tayo ng 2 equations. Tapos, separable naman siya into two tawag dito, differential equations na mas-solve mo independently. Okay? So, ayan. Ang point lang is that dissipative lang lagi yung isang ano lang. Pag pag hindi magka-combination yung capacitor and inductor, magiging dissipative lang. Okay? Okay. Okay, so this ends the chapter. Ends the chapter. Any questions? Any questions? So send nyo lang mamaya no, kung chat nyo lang picture ng solution nyo kung gusto nyo i-try yung sa part na to. Yung dito sa part na to. I think mas madali kung i-revert back nyo itong form nito. I-revert back mo siya dun sa cosines and sines. I think feel ko mas practical. Well, mas mahaba yung differentiation process pero more terms lang naman. Sir, isang student lang po ba makakatanggap ng bonus grade para sa pinasolve mo? Hindi. Lahat ng magsisend. Lahat ng magsisend. Within today lang. Okay. So, lahat ng magsisend may medyo may malaking bonus. Okay? Okay, sige. Kung wala ng question, wait, stop share ko na.